Hi guys, so let's see another problem from LeetCode, and I think it's a second problem from the day 5th of driver sheet linked list. So this problem is 876, middle of the linked list, and linked list is again a data structure where nodes are linked to the other nodes by a next pointer. So now we are given a head of a singly linked list. So singly linked list is a linked list in which we only have a next pointer. We cannot traverse to the previous elements. We can only traverse to the next element in a linked list. Now we need to return the middle node of the linked list. Okay. There are two middle nodes, return the second middle node. So let's see what this question is saying, that we are given 1, 2, 3, 4, and 5. These are the nodes of the linked list, and the length of the linked list will be 1, 2, 3, 4, 5, right? So if 5 divided by 2, this is going to give me 2, and I need to return. Yeah, so if 5 divided by 2, it's not going to be 2 actually, because it's an integer division. We need to divide it by 5. Yeah, so 5, we need to check if it is divisible by 2 or not, and after dividing them, the answer will be 3, right? Because 5 divided by 2 is going to give me 2.5, which is the seal value, that is the 3. So we take 3. But now you must be wondering that if we have the linked list as, let's say, if we have this linked list where we don't have 5, where we only have these 4 elements, right? What will be the middle in that case? In that case, we have this 4. Now 4 divided by 2 is going to be 2, right? But 2 is not the case, because we need to return the second middle. For this case as well, the value will be um, 1, 2, 3, and 4. So 4 divided by 3, 4 divided by 2 is also going to give me 3. And if we can understand that in integer division, because in most of the languages, I think in C++ and Java, integer division is supported, and I think it's by default the integer division. So what we will do is, we will just simply say that n by 2 plus 1, this is our middle element, that's it, and we are done, right? So we need to return these middle elements, and if in case we have, let's say for these are the two middle elements, then we need to return the second one, that is this 3. Now the question is how we can solve this, right? And this is not just like that we will be returning return the middle node. Yeah, so this is not, so we need to return this node, and from there on, the iterator will go on traversing the linked list, and it will verify that it is the same linked list or not, and we are good to go. So now let's see how we can solve this problem. I think the one that very basic thing that will come to everyone's mind will be that we can store the element, or we can, not just store the element. We can simply just, let's say, count the length of the element. So we'll count the length, not the element actually, sorry, the linked list. And let's say the length is n. So we are very simply say that the middle element will be n by 2 plus 1 by the formula that we have seen earlier. And then we will iterate over the linked list till we have reached the n by 2 plus 1, and this is the middle node, which is equal to linked list at n by 2 plus 1, and then we will return the middle element. Like, this is one of the way. And if we will analyze it, then the time complexity that it will take is n, order of n. Why? Because it's linearly traversing the element for the length, and then we are also traversing the n by 2, which is on average is n. So order of n will be the time complexity, but time function is going to be, but the time function is going to be somewhat like this, 2 of n, right? And the space complexity is constant. We are not storing any nodes, we are not using any hash map for nodes, so that will be constant, because we are using only two variables, that is length and middle. So space complexity will be constant. Now if I am in an interview, if I am sitting in an interview and this question comes up, then the interviewer will say that, okay, fine, that you have come up with this approach, can you optimize it, can you do it even faster, can you, not faster, but can you optimize the code? And because right now the time function says that we have two passes, right? First one will be to calculate the length. The second one will be to get the middle element. So there are two passes right now. And an optimized way of this will be to not use two pass, to only complete it in a one single pass. Let's see how we can do this. For this, we need to understand some mathematical concept first. Let's say this is a racetrack, right? This is a racetrack, and there is this car, and there is this car. Let's say this car is fast and this car is slow. So fast covers twice the distance of the slow car in 1 unit of time, which means that the velocity of fast car is going to be 2 times the velocity of second car, slow car, right? I mean, that's pretty obvious, because if someone runs, if someone, let's say two of the people are, if two of the students are competing in a race contest, and the first student, the faster student, covers twice the distance of the slower student at at every unit of time, then we will say that the velocity of the faster student is twice the velocity of the slower student. So this thing is fine, right? Now I will say that at some time at t is equal to, let's say at some time t, the distance covered by the faster student is xf, and the distance covered by the slower student is xs. And because of this relationship, I will say that t is equal to divide by t, but the slow should be multiplied by 2, right? Because I have simply created this equation with the help of this and these two equations. I have created this one equation, and if we want to solve this equation, t will be cancelled out, and I will say that xf is equal to twice of xs, which means that the distance covered by the faster student will be twice the distance covered by the slower student at a t unit of time. Which means that if I will say that, let's say, like a coordinator of the race simply ask the students to pause or ask the cars to pause, then at this point where the time is t, where the time is equal to t, the distance covered by the slower car and the distance covered by the faster car, so faster car is going to cover, if slower car is covering x, then faster car will cover 2x. This is the relationship that I want you to know. Now if this is the case, how we can apply this in our linked list? Let's say this is a linked list 1, then we have 2, then we have 3, then we have 4, right? Now I have a slow pointer pointing, now I have a slow pointer and a fast pointer initially pointing at null. Now fast pointer is going to increment by 1, and sorry, the fast pointer is going to increment by 2 and slow pointer is going to increment by 1. So slow pointer will be jumping on this element, right? Slow pointer will go like this, then this, then this, and this, and fast pointer will somewhat go like taking a jump of 2 and then taking a jump of 2, right? So if this is how the pointers are going to cover the distances, if you will see carefully that t is equal to this point, the slow pointer and fast pointer are pointing on the same element, but a very strong but. Slow pointer has to make 2 jumps for that, because it has to make an initial jump and then it has to make a second jump. So the xs will be, the distance covered by xs at this second node is going to be 2, and xf will be at second node is going to be 1. And by the same relationship, if I will say that the xs is going to be n, then obviously xf is going to be n by 2, right? I mean, this is a pretty simple and surreal thing, that this is how things will work. And if I want to check that if yeah, and this thing will be managed by this fact that we don't need to plus 1. Why? Because if I have, let's say, 5 here, let's say I have a 5 here and then 6, right? But we only have 5 elements. Then at 6th position, it is going to take the middle as 3, but we are not at 3, right? We are at 5. And at 5 also it's going to take the middle as 3, because at 5 the middle should be 3, and at 6 as well the middle should be 3. So this is how it's going to calculate. And now the code part. So the time complexity of this solution as well, that is the single pass solution as well, is going to be linear time, and space complexity is also linear time, and space complexity is also constant. Why? Because we are using only two pointers, that is slow and fast pointer. And if we talk about the solution, then we need these two pointers, right? After having these two pointers, what we can do is set a condition that if fast or fast of next is not null, until then we will be running our while loop, and slow will be incrementing just one by one, and fast will be incrementing on two paces. That is, it will be jumping two nodes and it will be jumping only one node. And at last, when we have exhausted our fast variable, fast pointer, that it's now pointing on a null value or it's pointing on an element, that is the last element, right? Because there can be a case when, let's say this is a fast pointer, and now the fast pointer is pointing at this value, that is null. In that scenario, so this is a fast, let's say the fast will be moving like this. So initially it jumps from okay, so initially the fast is on this pointer, and now it jumps from this length, that is a fast next of next, and then it jumps from this length, and now it's pointing on null, right? And if we talk about slow, slow will be initially at head, and now it's pointing on this one. So when my fast pointer was at this node, then slow was at this node, and the slow will be again pointing again. And now the next is fast pointer is exhausted, and now I will know that the slow pointer is on the other node. The node which is pointed by the slow node, the slow pointer, is my middle node. And you can clearly see that by this concept, that 4 by 2 is going to be, sorry, 4 by 2 plus 1 is going to be the middle element, and that is 3. And yes, 1 2 3 and 4, and it's pointed by 3, right? By this concept we can easily see that it's pointed by 3, and that is what we need. So slow pointer will give us the middle node, and again the time complexity will be n, and space complexity will be constant. So I hope the solution is clear. Thanks guys, see you in a bit.